Hello. So parabolas are the graphs of degree 2 polynomial. So here I have the graph of two different parabola, one red and one in black. The red one, it's a convex. The coefficient of x squared is a, is positive. And in black, I have negative value of a. A is the coefficient of x squared. The x-intercepts are x1 and x2. The vertex of the parabola has these coordinates, x of the vertex, y of the vertex, or turning point, we call this point here, okay? And the parabola is symmetric with respect to this axis, the artificial axis here, through vertical axis through the vertex, okay? So this x-intercepts, x1 and x2, they may or may not exist, but they might not be real numbers. For instance, the red parabola does not intercept the x-axis, so there are no solutions for the red equation. For the red parabola equals to 0, there's no solution, right? But for the black parabola we have, and the solutions are given by our good old formula, minus b plus or minus delta, square root of delta over 2a, where delta is b squared minus 4ac. So this has to be non-negative. So we can take the square root and still find a real number. If this delta is negative, the solutions are non-real numbers, and we're not going to see that. So three possible equations for the parabola are in terms of our coefficients a, b, and c. We can have, if we have real solutions, x1 and x2, right? x2 and x1 here, we can express the parabola like this. And in terms of the vertex of the parabola, x of the vertex and y of the vertex, we have this equation here in the middle. For instance, looking at this equation here in the middle, if x is equal to x of the vertex, this is 0. So this whole term is 0, and then y is just going to be y of the vertex. So if x is equal to x of the vertex, y is going to be the y of the vertex. That's the vertex point here, right? So expanding this, we find the three equations, the following three equations, okay? So I just expanded. I multiply x by x, I found x squared, x by minus x2, minus x1 times x, minus x1 times minus x2. Then I multiply everything by a, and I found this equation here. I expanded my square here. I found my second equation here. Okay, that's how I found the equations. But then I'm comparing the coefficients here of degree 1 that are multiplying x. Here I have b, here I have minus 2ax of the vertex, and here minus a, the sum of x1 and x2. And I wrote here in green the three coefficients of x to the power 1, the linear term. This equation here, solving for the x of the vertex, I find minus b over 2a, right, the x of the vertex. Using these two parts here, solving this equation here, I get this other formula for the vertex of the parabola. The vertex is the middle point of x1 and x2. Remember the symmetry of the parabola, right? The vertex is right in the middle of x1 and x2. So two formulas for the vertex in terms of the roots or solutions to the parabolic equation, and x in terms of the coefficients a, b, and c. Does not depend on c. Okay, now I also compare the degree 0 terms of the three equations, and I found these formulas here, the first line on top. ax1, x2 equals ax of the vertex squared plus y of the vertex, and that's equal to c. Looking at this equation here, I found the y of the vertex is the c minus this. Then I substitute by this formula here, x of the vertex minus b over 2a, minus b over 2a squared. I do some algebra, and I found that the y coordinate of the vertex, the turning point of the parabola, is equal to minus delta over 4a, where delta is our usual discriminant of the parabola. Okay? So the y coordinate of the vertex of the parabola is minus delta over 4a. Okay? So lots of nice facts about the parabola. Knowing the three formulas here is quite important. The three ways you can write a parabola, the equation of a polynomial of degree 2. Okay, the factorized way on the vertex formula and the usual formula with coefficients a, b, and c. Okay, that's all. Thank you. Bye-bye now.